Let's continue with some more MCQs on acceleration due to gravity, and in this case typically acceleration due to gravity at a height. Next question. Value of g at a height of 320 meter from the surface of the earth is 9.8 meter per second square, 10.6 meter per second square, 9.799 meter per second square, or is it 10 meter per second square? Now please note what height it is at. It's at a very small height, 320 meter, nothing. Okay, compared to the radius of the earth, 6,400 kilometers, 320 meters is very small. Now approximately it is very close to the surface of the earth. If it is very close to the surface of the earth, you know what is the acceleration due to gravity on the surface of the earth? It is 9.8 meter per second square. Okay, where is it? A is the answer, 9.8 meter per second square. But look at the option C. The option C is very close, 9.799. Approximately it is like nearly 9.8. So there's a catch over here. I would have given a wild guess and considered 9.8 as the answer, but since A and C are so close to each other, I'll have to actually solve this question. So B and D I did not discuss because it's way up ahead. 10 and 10.6 not possible. Okay, if you're going to a height, as you go higher and higher and higher, acceleration due to gravity goes on decreasing, and this is like more than 9.8. so B and D I'm not looking at also. Okay, so in this case my challenge is it A or is it C? So let's solve. Now acceleration due to gravity at a very small height, you remember we did the formula in the previous module. G at a very small height is given as formula G into 1 minus 2h upon r. Correct? So let's substitute. Height is given, h is 320 meter, and radius of the earth, 6400 kilometer, and acceleration due to gravity on the surface is 9.8 meter per second square. So substituting, g as 9.8, 1 minus 2h, h is 320 meter, upon r is 6400 kilometer, that is 64 into 10 raised to 5 meters, and then finally just calculating, I get the simplification as gh is equal to 9.8 brackets 1 minus 640 upon 64 into 10 raised to 5, cancelling 64 tens are, and finally I get it as 9.8 into 1 minus 10 upon 10 raised to 5, that becomes 10 raised to minus 4. So solving the brackets first, 9.8 brackets 1 minus 10 raised to minus 4 is 0.0001. So 1 minus that, it becomes 9.8 into 0.9999, which becomes equal to 9.799 meter per second square. So what's the answer? Yes, the answer is C option, 9.799 meter per second square. Actually it's almost 9.8, but then the options were very close by, that's why we needed to solve this. Okay, let's see one more question. Acceleration due to gravity at a height from the surface of the earth. Oh, a very simple one, a straightforward question, knowledge based. You remember the formula? G at a height in terms of small g. What was it? You remember this slide? We solved it and found out g at a height is given as g into r upon r plus h the whole square. So the answer would be yes, A answer. Let's go to the next question. Okay, this one I want you to solve with me. Acceleration due to gravity at the height above the surface of the earth is 1% that on the surface of the earth. The height from the surface of the earth is how much? H is asked, and that too in terms of capital R, that is the radius of the earth. So A option is either it is h equal to 2r, or h equal to 9r, or h equal to r, or h equal to 10r. Let's solve this. Now you know the fundamental formula for g at a height in terms of small g, that was equal to g into r square upon r plus h the whole square. Now in this case, GH is 1% of that on the surface, that is GH is 1% of G. So you can see what I've done. In place of GH, I have substituted 1 upon 100 into G. is equal to G into R square upon R plus H the whole square. So cancelling G on both the sides and taking square root, I get 1 by 10 is equal to R upon R plus H. Now it's a very simple calculation, just cross multiplying on both sides, I get R plus H is equal to 10R. So H is equal to 10R minus R, that is 9R. And your answer in this case will be yes, B option, H is equal to 9R. Got it?